Alright, this is a demo of my dart project circuit for lab. So in this circuit, we would throw 2 darts at a board, and they would get a score between 0 and 3. And we want to take that score and make a circuit that will keep track of the score and then tell the player if their number was less than 3, equal to 3, or greater than 3. So for the circuit, I took the inputs from each dart score and put it into an encoder. So dart 1 I assumed that it would be a low to make it easier for this project. So for 1, 2, and 3, if one of those went low, then it would use that number as to feed onto the rest of the circuit. And I did the same thing for dart number 2. I then fed that into an adder, which would then add the inputs together, and then it would output them as a 3-bit binary number. I then took that number and took it to both a display driver and a comparator, which is down here. So with the display driver, I just took the numbers in and then sent it to the 7-segment display. And then down here with the comparator, I compared the inputs from the adder to the number 3. And then on the outputs, I inverted it and then took it to an LED so that LED would light up when that condition is met. I did that with all 3 of the outputs. So over here I have my circuit. You can see that the score is currently 0 because there's been no inputs. Actually, I should show you the truth table first. Okay, I got my truth table. So, a little bit of stuff. The X, it's irrelevant. It doesn't really matter. It won't change the operation of the circuit. For yellow, or for when the LED is yellow, that means that the number is less than 3. When it's green, it is equal to 3. And when it is red, it is more than 3. This just makes it easier to see the number that you're getting out. So here's the truth table. Then I'll move back to the circuit. So right now it's 0 because I have no inputs. And then when I make it, let's give it a 1. So this would be a 1 score for the first dart, which is a 1, which means that the yellow LED should be on. And that is true for the truth table. So then let's also do that with the other one. Also a 1, which means that the yellow LED is still on. Now let's get a 2. So we can do this in 3 ways. Getting a 1 and a 1 will give you 2. Okay, I turned on the wrong one. Oops. Okay, a 1 and a 1 will give you 2. Or you could have a 2 and a 0. That will also get you to 2. Or you can have a 2 and a 0 on the other dart, and that will also get you to 2. So now 3. We can have just a 3 on one dart. That'll get us up to 3. We can have a 3 on the other dart, and that will get us up to 3. Or we could have 2 on one dart, 1 on the other. That'll get us to 3. Or we could have 1 on one dart and 2 on the other. And that will get us to 3. Now 4, the easiest way to do this is, there's multiple ways to get to 4 again, but there's the 3 on one dart. That'll get you up to 4, and that red LED is on, signifying that it's too high. You can have 2 on each dart, which will also get you to 4. and again the red LED's on. Or you could have 3 on one dart and 1 on the other again, and that gets you to 4. So then for 5 there's only 2 ways to get it. It's 3 on one dart, 2 on the other. And then the other way around, 3 on one dart, 2 on the other. So that's 5. And then 6 is 3 on both darts. So, and then that matches the truth table, so everything looks all good. So that's the Dart Project lab demo.